POM Overview in Maven. Here you can see POM Overview. Here the asterisk element with asterisk element may be overwritten, at least mostly by profile element settings. And elements with here element with double asterisk profile elements are the asterisk dash suffixed elements. Here this sign contains elements for meant inheritance. Maven projects dependencies, builds, artifacts, all of these are objects to be modeled and described. These objects are described by an XML file called a project object model. The POM tells Maven what sort of project it is dealing with and how to modify default behavior to generate output from source. In the same way, a Java web application has a web.xml that describes, configures, and customizes the application. A Maven project is defined by presence of pom.xml. It is a descriptive declaration of a project Maven. It is the figurative map that Maven needs to understand what it is looking at when it builds your project. You can also think of pom.xml as an analogous to makefile or an ant build.xml. When you are using GNU make to build something like MySQL, you will usually have a file named makefile that contains explicit instruction for building a binary from source. When you are using Apache Ant, you likely have the file named build.xml that contains explicit instruction for cleaning, compiling, packaging, and deploying an application. Make, Ant, and Maven are similar in that they rely on presence of a commonly named file such as makefile, build.xml, or pom.xml, but that is where the similarities end. If you look at Maven pom.xml, the majority of POM is going to deal with descriptions. Where is the source code? Where are the resources? What is the packaging? If you look at an ant build.xml file, you will see something entirely different. You will see explicit instructions for tasks such as compiling a set of Java classes. The Maven POM is declarative, and although you can certainly choose to include some procedural customizations via the Maven Ant plugin, for the most part you will not need to get into gritty procedural details of the build if your project's built. POM is also not specific to building Java projects. While most of the while Maven default plugins are targeted at building jar artifacts from a set of source, test, and resources, there's nothing preventing you from defining a POM for a project that contains C# resources and produces some proprietary Microsoft binary using Microsoft tools. We have established that the POM describes and declares. It is unlike an AND or make in that it doesn't provide explicit instructions, and we have noted that POM concepts are not specific to Java. Here you can see the project object model and overview. POM contains 4 categories of description and configuration. The general project information. This includes a project name, the URL for a project, sponsoring organization, a list of developers and contributors, along with your project, along with your contributors, along with the license for a project. In build settings, in this section we customize the behavior of the default Maven build. We can change the location of sources and sets and tests. We can add new plugins. We can attach plugins goals to the lifecycle, and we can customize the site generating parameters. Build environment. The build environment consists of profiles that can be activated for use in different environments. For example, during development, you may want to deploy to a development server, whereas in production you want to deploy to a production server. The build environment customizes the build settings for specific environments. And is often supplemented by custom settings.xml in title/.m2. And POM relationships. A project rarely stand alone. It depends on other projects, inherits POM settings from parent projects, defines its own coordinates, and may include submodules. And if we reconsider this, POM stands for Project Object Model. It is an XML representation of a Maven project held in a file named pom.xml. When in the presence of Maven folks, speaking of a project is speaking the philosophical sense beyond a mere collection of files containing code. A project contains configurable files as well as the developers involved and roles that they play, and the defect tracking system, the organization and licenses, the URL of where project lives, the project dependencies, and all of other little pieces that come into play to give code life. It is a one-stop shop for all things concerning the project. In fact, in Maven world, a project does not need to contain any code at all, merely a POM.xml. The POM contains all necessary information about the project, as well as configurations of plugins to be used during the build process. It is declarative manifestation of who, what, and where, while build cycle is the when and how. That is not to say that POM cannot affect the flow of the life cycle. It can. For example, by configuring Maven-Antran-plugin, one can embed Apache and task inside the POM. It is merely a declaration, however, whereas a build.xml tells and precisely what to do when it is run procedural. The POM states its configuration declarative. This the external force causes the lifecycle to skip the ant plugin execution. It does not stop the plugin that are executed from doing their magic. This is unlike a build.xml file, whereas tasks are almost always dependent on the lines executed before. Here, Maven coordinates the POM defined above is the bare minimum. Here group ID colon artifact ID version group ID colon artifact ID version are group ID colon artifact ID colon version are all required fields. All the group ID and version do not need to be explicitly defined if they are inherited from a parent. These three fields act much like an address and timestamp in one. This makes a project place in a repository act like a coordinate system for Maven projects. Project ID, this is generally unique amongst an organization or a project. For example, all core Maven artifact do well should live under the group ID org.apache.maven. Group IDs do not necessarily use the dot notation. For example, the JUnit project. Note that the dot-noted group ID does not have to correspond to package structure that the project contains. It is, however, a good practice to follow. When stored within a repository, the group acts much like the Java packaging structure does in an operating system. The dots are replaced by OS-specific directory separators such as / in Unix, which becomes a relative directory structure from the base repository. Artifact ID. The artifact ID is generally the name that the project is known by. Although the group ID is important, people within the group will rarely mention the group ID in discussion. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Along with the group ID, the artifact ID fully defines the artifact's living quarters within the repository. As an example, my dash project lives in $m2_repo/org/code/host/mojo/my project. Version. This is the last piece of the naming puzzle. Group ID colon artifact ID denotes a single project. But they cannot delineate which incarnation of the project that we are talking about. Do we want JUnit colon JUnit of 2008 version 4.12 or of 2007 version 3.8.2? In short, code changes. Those changes should be versioned. In this element keeps those versions in line. It is also used within an artifact repository to separate versions from each other. For example, my dash project version 1.0 files live in the directory structure $m2 underscore repo /org /codehost /mojo my project /1.0. These three elements given here to a specific version of the project here, letting Maven know who we are dealing with and when it's in its software life cycle we want them. With regarding packaging, now that we have our address structure of group ID colon artifact ID colon version, there is one more standard label to give us a really complete what, that is project packaging. For example, POM for org.codehost.mojo colon my dash project colon 1.0 define can be packaged as a jar. We could make it into WAR by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is default jar. POM relationships. The most powerful aspect of Maven is its handling of project relationships. This includes dependencies and transitive dependencies, inheritance, and aggregation. Multi-module projects. Dependency management has a long tradition of being a complicated mesh for anything but the most trivial of project. Jarmageddon quickly ensures as a dependency tree become a large and complicated. Jar hell follows where versions of dependencies on one system are not equivalent to the versions developed it either by wrong version given or conflicting versions between similarly named jars. Maven solves both problems through a common local repository from which to link projects correctly, versions and all. Dependencies. The cornerstone of POM is its dependency list. Most projects depends on others to build and run correctly. If Maven does for you, this is if all Maven does for you is manage this list, you will gain a lot. Maven download and links the dependencies on compilation as well as on other goals that require them. As an added bonus, Maven brings in the dependencies of all those dependencies, transitive dependencies, allowing your list to focus solely on dependencies that your project requires. One of inheritance. One powerful addition that Maven brings to build management is concept of project inheritance. Although in build systems such as Ant, inheritance can be simulated, Maven makes project inheritance explicit in the project object model. And the super POM, POM, similar to inheritance of the objects in object-oriented programming, POMs that extend parents' POM inherits certain values from the from that parent. Moreover, just as Java objects ultimately inherits from java.lang.object, all project object models inherits from a base super POM. Dependency management. Beside inheriting certain top-level elements, parents have elements to configure values for child POMs and transitive dependencies. One of these elements is dependency management. It is used by POMs to help manage dependency information across all of its children. If my dash parent project uses dependency management to define a dependency on JUnit colon 4.12, then POMs inheriting from this one can set their dependency giving the group ID equal JUnit and artifact ID equal JUnit only, and Maven will fill the version set by the parent. The benefit of this method are obvious. Dependency details can be set in one central location which propagate to all inheriting POMs. Aggregation or multi-module. A project with modules known as a multi-module or aggregator project. Modules are projects that this POM lists and executed as a group. A POM package projects may aggregate the build of a set of projects by listing them as modules, which are relative path to directories or POM files of those projects. Properties are the last required piece to understand POM basics. Maven properties are value placeholders like properties in AND. Their values are accessible anywhere within a POM by using the notation $, open curly brace, close curly brace, where X is the property, or they can be used by plugins as default values. And in this diagram you can see properties here. Build settings. Beyond the basics of POM given before, given here, there are two more elements that must understood before claiming basic competency of the POM. They are built element that handles things like declaring your project's directory structure and managing plugins, and reporting elements that largely mirrors the built element for reporting purposes. The built, according to the POM 4.0.0 XSD, the built element is conceptually divided into two parts. There is a base build type which contains the set of elements common to both built elements, the top level built element and the project, and the built element and the profiles covered profiles. There's a build type which contains base build set as well as more elements on for the top level definition. The basic built element set. Base build is exactly as it sounds, the base set of elements between the two built element in the POM. Resources, another set of built element, is specifying where resources exist within your project. Resources are not usually code. They are not compiled, but are items meant to be bundled within your project or used for various other reasons such as code generation. Plugins, beyond the standard coordinate of group ID colon artifact ID colon version, there are elements which configure the plugins or this build interaction with. plugin management is an element that is seen along site plugins. Plugin management contains plugin element in which the same way, except that rather than configuring plugin information for this particular project build, it is intended to configure project builds that inherit from this one. However, this only configured plugins that are actually referred within the plugin element in the children or the current POM. The children have every right to override plugin management element definitions. The build element set, the build type in the XSD denotes denotes those elements that are available for the project build. Despite the number of extra elements, 6, there are really only 2 groups of elements that project build contains that are missing from the project from the profile build: directories and extensions. Directories, the set of directory element live within the parent build element, which set various directory structures for the POM as a whole. Since they do not exist in profile build, these cannot be altered by profiles. Extensions are a list of artifacts that are to be used in this build. They will be included in the running build class path. They can enable extensions to build process, such as add an FTP provider for the Maven transport mechanisms, as well as make plugins active which make changes to the build lifecycle. In short, extensions are artifacts that are activated during build. The extensions do not have to actually do anything for content mojo. For this reason, extensions are excellent for specifying one out of multiple implementation of common plugin interface. Reporting contains the elements that correspond especially for the site generation phase. Certain Maven plugins generate reports defined and configured under report element. For example, generating Javadoc reports. Much like the build element's ability to configure plugins, reporting commands the same ability. The glaring difference is that rather than fine-grained control of plugin goals within the executions block, reporting configures goals within report set elements. And subtler difference is that a plugin configuration under the reporting element works as a build plugin configuration. Although the opposite is not true, a build plugin configuration does not affect a report plugin. Report sets. It is important to keep in mind that an individual plugin may have multiple goals. Each goal may have separate configuration. Report sets configure execution of a report plugins goals that does this familiar deja vu. The same thing was said about build's execution element, with one difference: you cannot bind a report to another page. Sorry. Here you can see more project information. Several elements do not affect the build, but rather document the project for the convenience of developers. Many of these elements are used to fill in project details when generating the project's website. However, like all POM declarations, plugins can use them for anything. Followings are the simplest element: name, description, URL, inception. Here, name. Projects tend to have conventional names beyond the artifact ID. The Sun engineers did not refer to their project as Java-1.5, but rather just called it Tiger. Here is where to set that value. Description, a short human readable description of the project. Although this should not replace formal documentation, A quick comment to any readers of the POM is always helpful. URL, the project's homepage. Inception year, the year the project was first created. Licenses are legal documents defining how and when a project or parts of a project may be used. A project should list licenses that apply directly to this project and not list licenses that apply to the project's dependencies. Organization. The most projects are run by some sort of organization, business, private group, etc. Here is where the most basic information is set. Developers. All projects consist of files that were created at some time by a person. Like other systems that surround a project. So to do this, people involved with a project have a stake in the project. Developers are presumably members of the project's core development. Note that although an organization may have many programmers as members, it is not good form to list them all as developers, but only those who are immediately responsible for the code. A good rule of thumb is if the person should not contacted about the project, they do not need to be listed here. Contributors are like developers yet play an auxiliary role in a project's lifecycle. Perhaps the contributor sent in a bug fix or added some important information. A healthy open source project will like to have more contributors than developers. In the environment settings, in the issue management, this define the defect tracking system, Bugzilla, TestTrack, ClearQuest, etc. used. Although there is nothing stopping a plugin from using this information for something, it's primarily used for generating project documentation. Continuous integration management. Continuous integration build system based upon triggers and timings such as hourly or daily have grown in favor over manual builds in the past few years. As build systems have become more standardized, so have the systems that run the trigger those builds. Although the majority of configuration is up to the specific program used, continuum, cruise control, etc., there are a few configurations which may take place within the POM. Maven has captured a few of recurring settings within a set of notifier elements. A notifier is a manner in which people are notified of a certain build status. Mailing lists. Mailing lists are a great tool for keeping in touch with people about project. Most mailing lists are for developers and users. SCM, the software configuration management, so-called the source code control management or succinctly version control, is an integral part of any healthy project. If your Maven project uses a SCM system, it does, doesn't it? Then here is where you place that information into POM. Prerequisites. POM may have certain prerequisites in order to execute correctly. The only element that exists as prerequisite in POM 4.0.0 is the Maven element, which takes a minimum version number. Repositories. Repositories are collection of artifacts which adhere to Maven repository directory layout. In order to be a Maven repository artifact, the POM file must live within the structure $base_repo /group ID artifact id /version / artifact id -version.pom. $base_repo can be local file structure or remote based URL. The remaining layout will be same. Repositories exist as a place to collect and store artifact. Whenever a project has a dependency upon an artifact, Maven will first attempt to use a local copy of the specified artifact. If that artifact does not exist in the local repository, it will then attempt to download from the remote repository. The repository element within a POM is specify those alternate repositories to search. Plugin repositories are home to two major types of artifact. The first are artifacts that are used as dependencies of other artifacts. These are the majority of artifacts that reside within Central. The other type of artifacts is plugins. Maven plugins are themselves a special type of artifacts. Because of this, plugin repositories may be separated from other repositories, although I have yet to hear a convincing argument for doing so. In any case, the structure of plugin repositories element block is similar to the repositories element. The plugin repository element each specify a remote location where Maven can find new plugins. Distribution management. Distribution management act precisely as it sounds. It manages the distribution of the artifact and supporting file generated throughout the build process, starting with the last element first. Repository. Whereas the repositories element is specified in the POM the location and manner in which Maven may download remote artifact for use by current project. Distribution management specifies where and how this project will get a remote repository when it is deployed. Repository element will be used as for snapshot distribution if the snapshot repository is not defined. Site distribution. More than distribution to the repository, distribution management is responsible for defining how to deploy the project site and documentation. And relocation projects are not static; they are living things. A common thing that happen as project grow is that they are focused to move more suitable quarters. For example, when your next widely successful open source project moves under the Apache umbrella, it would be good to give users a heads up that the project is being renamed to org.apache.my-project:1.0. Besides specifying new address, it is good form to provide message explaining why. Profiles. A new feature of POM 4.0 is the ability of a project to change settings depending on the environment where it is being built. A profile element contains both an optional activation, a profile trigger, and a set of changes to be made to the POM. If that profile has been activated, for example, a project built for test environment may point to a different database than that of the final deployment, or dependencies may be pulled from different repositories based upon JDK version used. The element of profiles are there. Activations are the key of the profile. Power of profile comes from its ability to modify the basic POM only under certain circumstances. Those circumstances are specified via an activating element. The base built element set, if we revisited, The reasons for two types of built element reside in fact that that does not make sense for a profile to configure built directories and extension as it does in the top level of a POM. Regardless of in which environment the project is built, some values will remain constant, such as directory structure of a source code. If you find your project needing to keep two sets of code for different environments, it may be prudent to investigate refactoring project into two or more separate projects. Here you can see POM, and you can see POM relationships. Under that you can see coordinates. Under that you can see group ID, artifact ID, and version. You can see on aggregation, and you can see modules under that, and you can see inheritance under POM relationships. Here you can see parents, dependency management, and under dependencies you can see dependency management and dependencies. Here you can see project information under POM, and you can see name, description, URL, inception year, licenses, developers, contributors, and organization under project information. Here you can see build system under POM, and you can see properties, packaging, build, and reporting under build system. Here you can see build environment under POM, and you can see environment information, Maven, and Maven environment under build environment. You can see issue management, CI management, mailing list, and SCM under environment information. And you can see pre-request, repositories, distribution management, profiles under Maven environment. And you can see repositories, plugin repositories, and repositories and plugin repositories under repositories. And you can see profile under profiles, and activation and suffix elements under profile. Here you can see element may be overridden at least mostly by profile element settings. Here modules, dependency management, build, reporting, repositories, plugin repositories, distribution management, and profile elements that are the asterisk dash suffix element here under profile. These are the element contains element meant for inheritance. Here you can see dependency management and build. Here now this is the end of my presentation. Thank you very much for watching it.